Hey GED students, it's GED question of the daytime, and we're still playing Two Truths and a Lie, GED style. I want to talk about fractions because, like the last little example question of the day we did with like terms, fractions are another area that people really screw up. So we see one of the statements below is a lie. Can you spot the fraud? Let's take a look at these statements here. So first one says 3 is equal to 9/3. Now, students right away tell me, Kate, that's a lie. Oh my gosh, how could a fraction be equal to a whole number? Impossible. Yeah, we really need to think about this. So guys, let's remember what a fraction bar means. Literally, a fraction bar means exactly the same as a divided by symbol. Literally, 9 over 3 is 9 divided by 3. Literally, it is 9 things divided into 3 equal groups. 9 divided by 3, or in pictorial form, 9 things broken into 3 equal groups. And of course, 9 divided by 3 is 3. So 9 divided by 3 equals 3. This was a true statement. Don't be fooled. Okay. Next one I want to look at. This is interesting to me. So this particular student says, let's take 2/3 and add it to 3/5, and we're going to get 5/8. Now I can see what that student did. They just added across the top. 2 plus 3 is 5. Added across the bottom. 3 plus 5 is 8. And said, ta-da, I added fractions. Now, this is the student who's made a really big error. Let's talk about why. Since the beginning of math, regardless of what you're adding and subtracting, we've only ever been able to add the same kinds of things. Let's say, you had word problems that said stuff like Johnny has 3 apples and Tina has 4 oranges. If you try to add these two, 3 apples and 4 oranges, I ask my students, well, how much is 3 apples plus 4 oranges? People are like, well, it's 3 apples and 4 oranges. And I'm like, you're right. 3 apples plus 4 oranges is 3 apples and 4 oranges. I can't add it unless some people will tell me, well, Kate, that is 7. And I say to them, 7 what? 7 what? It's certainly not 7 apples. I only had 3 apples. And it's not 7 oranges. I only had 4 oranges. But if you, and this is a weird thing students try to do in math. They try to like apple orange things. It's 7 apple oranges. No, if we put those individual things together, they're not going to suddenly become something new. They're not going to become apple oranges. Okay. So same thing here. If I want to add them together, apples and oranges, I'd have to call them by the same name. I have to say, oh, how many pieces of fruit? As soon as they're the same kind of thing, power to add granted. Oh, that's 7 pieces of fruit. I can add when I have the same kind of thing. And it's exactly that way in fractions. Remember that a numerator of a fraction, numer means to count. That tells you how many. But a denominator of a fraction, denom, means to give name to. That tells you what kind or what size. We can only add the same kinds of things. So we can only add things with common denominators. Okay, these two fractions currently, 2/3 and 3/5, cannot add in this form. You would have to give them what's known as a common denominator, the same size bottom, before you could add them. The student did not understand that, and so they made a silly little error here. Again, if you wanted to do that, I'll do it over here. The rest of you can just like skip right through this part if you don't want to talk about adding fractions today. But if I really wanted to do that, I'd have to think about thirds and fifths. And the first time I could cut thirds and fifths into the same number of pieces. Well, I could certainly do that. So thirds and fifths are different sizes. They're different size pieces, so they're different kinds. I could certainly do that if I took all the thirds and cut them into 5 pieces, and all the fifths and cut them into 3 pieces. Then I would end up with a total of 15 pieces in both my pies, and now everything is the same size. And so that's what I would do. I would slice these into fifths by multiplying everything by 5 over 5. Slice those pieces in thirds by multiplying everything by 3 over 3. And this is not a lesson on adding fractions today. So I'm flying through this, okay? But I would end up with 10 15ths here, 9 15ths there. And if I add 15ths and 15ths, of course I still have 15ths. Just like when I added fruit and fruit, I still had fruit. In this case, it would be 19 15ths, which also could be written one other way, 1 and 4 15ths. Both of those, either of those would be right answers, but neither of them are equal to 5/8. Okay, so let's just make sure that C was true. Seems like B is the lie. Why did I cross it off when I'm looking for a lie? So I'm seeing that B is a lie, but let's just make sure that C really is a true statement, because students do this silly all the time. Now students tell me all the time, Kate, 1/2 must be larger than, I'm sorry, let me say that again. Students tell me all the time, Kate, 1/2 must be smaller than 1/3. That's what students tell me. 1/2 must be smaller than 1/3 because 2 is smaller than 3. And I go, oh yeah, let's evaluate that statement. So 1/2 means I have one whole thing and I've cut it into 2 equal pieces. And 1/3 means I have one whole thing and I've cut it into 3 equal pieces. If you cut a pie into only 2 pieces, your piece is bigger than if you cut a pie into 3 pieces. I just want you to imagine that my husband came home from work, said, where's the pie? And I say, honey, but I just ate 1 piece. Yeah, well, if that 1 piece was a whole half of the pie, I ate a ton of pie. Okay, so a half is definitely bigger than a third. This was a true statement here. It is not the lie. B is the lie. Okay, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.